Your
Yeah.
mate, did he say?
Except no, he called you primate.
Oh,
It always
did he?
sounds like playmate. I think he's a bit obsessed.
Yeah, I thought he said my mate. I'm not his mate.
Primate.
My
What,
mate.
Crookshanks?
Yeah, my mate. I think we're going to have to start a new game called Guess My Fallacy.
Well, you can just pick one with
I
Crookshanks.
know,
He does them
he's
all.
got all of them. Yeah, but which is
Yeah.
your best fallacy, Crookshanks? Which is the one that you covet so highly that of all of them? I bet it's got something to do with.
Primate. Why you want to tell me why you
Gas pressure.
posted something that refutes your own argument?
Sorry?
You want to tell me why you posted something that refutes your own argument?
What,
And then you
about
get all butthurt about it after we call you out?
The predictability of eclipses and how they count
Have you just dropped some bass or something,
the time
Crookshanks?
between eclipses. It didn't contradict my argument.
Yeah, it says, why are there no solar eclipse predictions? That's what your source says.
No, the source is how they counted between solar eclipses. You never heard of the Saros cycle, no?
I would like to see proof that the Saros cycle is accurate.
Well, go back through time and have a look at eclipses. You can
Okay,
prove
so
it
what
to
proof do you
yourself.
have then?
Prove it to yourself.
No, it's your claim.
What do you mean proof of what? The Saros cycle? Do you not think the Saros cycle exists or something? What's up with that?
I haven't seen any proof of it.
Have you not? You've never... I bet you've never even Googled it, have you? You bet you haven't,
Bye,
have you? You haven't.
Crookshank.
But
I'd
he
like
is
to see
now.
proof. Go ahead. I'll
Oh,
respond when
man.
there's something worth responding to.
Right, I'll put it in the chat for you. All right, I'll find it on Google for you.
No, I want Primate to do it because he brought it up.
Wiki, right? What?
Primate, do you have any proof?
What, you can't do Google searches anymore?
No, it's your claim. Why don't you
Your
prove
finger's
it?
broken. What was my claim?
This is
The Saros cycle accurately predicts eclipses by counting.
by counting.
No, I said that eclipses were counted,
You brought up the Saros cycle.
and then the Saros cycle supports that claim.
Let's see some proof.
I didn't say it proved the claim, did I? I said it supports the claim.
Oh, okay. So I can support the claim that the Earth is a globe.
Do what you
I don't
want.
need any proof.
I don't have to believe you.
And then
Just
you're
because
just
you
wrong.
say it doesn't make it true, does
There you
it?
go.
Just because you
Saros is a
say the
period
Saros
of
cycle is used
exactly
doesn't make it true.
223 synodic months.
Just because you say that eclipses are counted doesn't make it true.
That the Saros cycle counts eclipses.
Yeah.
Prove it.
That
It's not
can
just
be
me
used
saying that,
to
is it?
predict eclipses
Prove it.
of the sun and moon. One Saros period after an eclipse, the sun,
ahead, Primate,
Earth,
prove it.
and moon. Can you not hear me?
Prove it the same way that you demand others prove the globe Earth.
Have a look in the chat, Crookshanks.
Which
Are you
one?
blind? Can you not read?
Which one?
Live stream text. Bev has just posted a wiki link to the Saros cycle.
Are links proof?
Well, you seem to think they are.
Do you think they are?
The link in itself is not, but the information contained within the link may be a good pointer.
Okay,
Not
good. So then I can do
not
the same thing.
necessarily proof, is it?
Okay, so I can do the same method, and then it would be valid as valid as your argument.
Sorry. Say that again.
If you come up with a proof, then you'd have one to counteract DP's one, wouldn't you? At least. But I mean, at the minute, DP's winning, as far as I can see. Well, what have you done?
Okay, so Primate, are links
he
proof?
said that.
All he's
Where's
done
yours?
here is come here and open his mouth. It's not actually.
I've heard this.
Yeah.
This is a tactic that I've heard quite a lot. This Crookshanks.
Yeah, it's called
you prove it.
using your guys' own poor logic.
I'm just gonna
and
say
watching you guys laugh at it.
you guys don't know what you're talking about. You prove it, and then we prove it to you, and then you say that's not proof. I need proof. So you don't. It doesn't really matter to you guys what happens, does it? You just completely deny it, and then have no proof of your own.
Congratulations, you're describing what Globers go through when they talk to you.
Why the fuck do you come here then, you
They
bellend?
have a good laugh. They like visiting the zoo.
The zoo.
So let me ask you something, Primate. If that supports your claim, then what does this support? Support my claim? All those links, all the information contained in all those links?
I haven't been through those links, so I really couldn't
because
tell.
you're
you.
lazy.
Is that McToon?
Yeah, McToon's
Oh my
first
God!
one.
You're
MC
not gonna give
Goon.
us McToon, are you?
MC Goon, the very first link.
That's called the genetic fallacy.
No, I've been through them. It's a load of bullshit. That guy has
Says
wrote
you.
down a load of bullshit. And
No,
you guys,
what you're saying is
you guys
bullshit.
just keep posting it, and it's a link to a load of bullshit. You can't
No,
defend
you're
any
bullshit.
of that shit.
You can't defend anything you say.
Yeah, of course you can.
And do you know what?
Yeah,
that's
sure you can.
exactly
So can MC2.
exactly as far as I got. Was the first one I saw. McGoon, Horizon does not rise to, and I was like, "That really? You're going to supply links to McGoon?"
The horizon doesn't rise to eye level. That's what I say.
No, that's obvious.
Prove
Isn't it?
otherwise.
Yeah,
If you can offer some kind of proof, you'd present it.
the horizon
The
doesn't
horizon
rise.
doesn't rise.
Yeah.
You don't listen,
Doesn't.
do you,
It
Crookshanks?
doesn't rise to eye level, right?
Yeah, it doesn't.
You
It can't
really
do, can
don't
it?
listen.
You for the good laugh.
Yeah. Have you helped fight the flat Earth yet with his horizontal like bending thing?
No, you're the one who needs help. You need to prove that plumb lines are parallel.
They are. They've already done it, dude.
No, you haven't.
Oh dear! You need to
have to
prove
prove
it.
it.
Plumb
Prove it.
parallel.
I have.
Go ahead, prove it.
The water level is horizontal. Already
So?
proved it. How do you want that
Ta-da!
proving?
Why don't you go measure the parallelism of two plumb lines?
Because they're perpendicular to the horizontal.
Those are all constructs. Those don't exist in the real world.
That's geometry, mate. Yeah, of course
Yeah.
they do.
Show me geometry in the real world.
Horizontal and vertical.
Have a look at the pyramids.
Mm-hmm. Yeah. What does that have to do with plumb lines being parallel?
Are you
Well,
in any
I'm sure
vertical?
they had to
Don't
use
answer
a
that
couple of
question. You only need
plumb
pyramids.
lines when building the pyramids.
Is there any chance, Crookshanks, that you can come back when I'm not here?
Yeah, sure. Why?
It's like you just don't come
Awesome.
back.
Why? Because you're a
Brilliant.
boring arsehole. And she's
Thanks.
fucking had enough of you.
Catch you later.
Wait a minute. Every time I'm here, you guys say come in VC, and now you want me to leave?
Well, you don't
No, I
bring
didn't want you
anything at all. You just say,
It's kind of
I don't
pointless.
know.
I'd rather
Yeah.
talk about something else, really.
I'm talking about the topic of this server, though. You guys said that the topic of here is the reality in which we live.
yes.
Yeah,
Yeah,
Mhm.
I just
well
did.
done. So bring something to the table,
Yeah.
Crookshank.
Okay. Here, plumb lines are
You
not
just
parallel.
claimed that geometry isn't
How-
used in the
how-
real world.
Are you going to do as a
Hello?
demonstration, Crookshanks, of why that happens?
I don't know. How am I going to just... I don't care why it happens. I'm talking about does it happen.
Walk us through it. Come on.
Plumb lines are not parallel.
Yeah, walk us through it. Rather than just saying it, walk us through it. How does the process occur where you end up measuring that plumb lines aren't parallel? What is
Oh, that's
what is the reference frame when you measure the plumb line not being parallel? What is the reference that you use to measure
Same
that
reference
the
that the plumb line
line
uses.
isn't parallel?
It's the reference that a plumb line uses.
The vertical.
Yeah.
Right. So it uses
There you
the
go.
vertical to measure
go.
that the
Same thing.
vertical isn't vertical, does it?
Yeah. Same reference.
Yeah.
It's just that the two verticals at different locations on Earth are not parallel.
What do you mean parallel? They just measure vertical, don't they?
Yeah, but if you take two of them and try to measure the parallelism, they're not parallel.
What's parallelism? What
Parallelism.
tool do you use for measuring parallelism, please?
Same tools that you use to determine that they're parallel.
What?
Same tools that you use to determine that they're parallel.
No, I use geometry and the horizontal.
So did I. So did I.
So
Which
geometry
horizontal did you use
measures
then?
parallelisms.
One at a time, please.
Go on, Bev.
Which horizontal do you use then?
One that's perfectly perpendicular to vertical.
Right. So how do you measure that the vertical isn't parallel then?
As you look at the measurement of the parallelism between two distant plumb lines.
Yeah, but the
Distant.
horizontal is perpendicular to vertical, right?
Each one of them, yes.
Right. So the horizontal is horizontal, is it?
Each one is horizontal, but they're not parallel.
What do you mean? What aren't parallel?
The horizontals and the verticals.
How do you measure that vertical isn't? How do you measure that horizontal isn't parallel? Please.
Fast, because you guys always interrupt me, so it's hard for me to get my point in. You understand that?
How
I
do
can
you
talk
measure
slower.
that horizontal are
See, Emma, how
not
you interrupted me?
parallel?
I have to talk fast, otherwise I get interrupted.
Not true.
Is that a tricky one? That. How do you measure that horizontals aren't parallel?
The same way that you measure that they are parallel. But doing it correctly.
That didn't answer the question,
Yeah, but
Crookshank.
what tool?
Oh, the surveyor tool is the same things that you use.
Oh, a
the
surveyor
water
tool.
level and the theodolite. Are you interrupting me when I'm talking?
What you're not talking about anything, are you?
Oh yeah, I'm talking about how you're wrong.
How I'm wrong doing what? Asking
Yeah.
you a question that you can't answer.
No, I answered it.
What you measured horizontals not being parallel with surveying tools.
Yeah, because we measured verticals not being parallel to each other. So by conclusion, the horizontal structure from each of those verticals is also not parallel.
Right, so you use a
You tried to
tool.
interrupt me again.
That sounds very cyclic, that, right?
No. Is a plumb line a tool?
The plumb line tool.
Yeah, is a plumb line a tool?
Yeah.
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 Oh, okay.
Do you
So
think
is a water level a tool?
Do you think surveyors use plumb lines?
Is a water level a
Do
tool?
you think surveyors use plumb lines?
Yeah, they use a zenith angle. It's built into a theodolite. I mean, there's just a more modern version of it. Like your phone can perform the same function, or a laser
zenith
level.
angle.
Do you think so? What's your point about using tools, though? I'm interested in that.
I'm just interested in you telling me which tools that the surveyors use to measure plumb lines. What's a zenith
Total
angle,
station.
please?
Zenith angle is straight above your plumb line. The line extending above your plumb line into upwards.
Oh, right. Can you make plumb lines do that? Go upwards?
Yes.
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 How would you do that?
Theodolite.
You could make a plumb line go upwards.
Yeah, you're confusing a plumb line with a plumb bob. A plumb line is just a geometrical line that's created by a plumb bob. Didn't know that, did you?
And you can extend it upwards, can you?
Yeah, you just ignore what I say. I know.
And whereabouts is that in the theodolite?
It's internal to it. It's a very precise angle measuring device.
That extends a plumb line upwards.
Constructs a line that you can use. Measure your zenith angle, yeah. Angle relative to the zenith, which is the same as a plumb line. Line that goes through the zenith. I thought you knew geometry.
Yeah, but they actually measure
Yeah.
the horizontal and then just go 90 degrees from horizontal, don't they? I mean, these tools.
No, because you can't easily construct a horizontal. Easier to construct the vertical line.
Well, that's what these tools do. They measure a level horizontal.
Sounds circular. You're using tools.
You're the one that says you know how they make plumb lines go upwards. I mean, which?
You ever use a plumb bob?
Yeah.
Yeah. How high is it?
Well, it's as long as you put the string, right?
Exactly.
Yeah.
Thank you for playing.
Right, so it can't go upwards, can it? It comes down, doesn't it? can only come down from
Unless
that
you
part.
start at the bottom
Can't
and look
make it go
upwards.
upwards. Well, no. Are you putting a helium balloon on it or something?
How do you get the plumb bob strung from the top of something anyway? Do you have to lift it up there?
Yeah, you're talking about a theodolite, aren't you? Wouldn't it be hanging from the
The
bottom
plumb
of a
bob.
theodolite, right? Be
Plumb
hanging
bob
from
is
the
a weight.
bottom of it, wouldn't it?
Plumb
It
bob
wouldn't
is a
be
string.
going upwards, would it?
A plumb bob is a weight hanging from a string. And which part of the plumb bob do you use to measure things from? Do you use the weight or do you use the string?
Use the line, but I mean that. Guess what? That's going to be underneath it as well. That's
Underneath-
presuming
underneath
that you put a plumb bob on the bottom of the theodolite, because I don't think you do you? Or you?
You know how
might do.
theodolite works?
Have you been watching people hanging plumb bobs from the bottom of theodolites?
Not in the
Or
modern
it
era.
was
We have
just
modern
that-
technology.
Is that what the surveyors were telling you? Which surveyors told you that? That's how you
The
use
civil
a
engineering
theodolite?
class that I took, where we studied the construction and use of this equipment.
The civil engineering class. Go on then. So what did he say when you were setting up your theodolite? What's step one? Get it out of the box.
Yeah. Step one's get it out of the box.
Right. Step two.
Step two is to put it on a tripod.
Brilliant.
Yeah.
Step three.
Turn it on.
Turn it on. Okay. Step four.
Step four is to take the measurement of your zenith angle.
Yeah. When were you going to level it? Or you
Level it. It's
is
self-leveling.
that-
You ever use the laser
right,
level?
you just switch it on, and that's it. You put it on a tripod, switch it on,
Yeah.
boom,
It's
off
got a
you go.
pendulum. It's got a pendulum with a couple of dual axis bearings, so it can swing downwards without any resistance. Pretty simple stuff. Have you ever used one?
It's got a pendulum.
Yeah.
Dual access bearings, did you say?
Yeah, it's got a couple of radial groove ball bearings so that it can rotate freely in two axes so that it's not encumbered by anything around it to be deflected from vertical. Pretty simple stuff.
Yeah, does that sound simple to you? Or does it sound like pretty complicated when whoever told you that and you thought, wow, that sounds great? Kosho was doing that sort of stuff. I've heard him do all that. It's as though you've heard something, got really confused by the person that's told you that.
I'm not confused at all.
That must be really good.
No,
I'll use that.
no, I'm perfectly
Okay.
clear understanding of how it works.
I'm sure everybody could really understand how a theodolite worked there.
Yeah, sure. You ever do any carpentry or construction or like, a house addition or something where you have to make a wall vertical?
Yeah.
Yeah, do you ever use one of those laser levels that projects lines that are perpendicular so you can help guide where the plumb line is?
No, not when I was putting walls up. No.
Yeah. Well, it's kind of modern technology and has a pendulum that swings in two axes, and so gravity always orients it vertically, as long as there's no friction or hasn't been knocked around too bad.
Them cheap lasers. Yeah.
You can pay $300 for them pretty easily.
Well, yeah, you could probably pay £1,000 if somebody paints it gold and tells you there's diamonds on it. But I mean,
No, just a regular plastic one with a proper
they're
green
just the
laser.
one for houses, right? For
$300.
the people use them for painting and putting pictures up and all of that sort of stuff. Yeah, like just a bog standard cheapy little laser, home laser thing. That's not a
Here,
theodolite.
I'll link
is
you
it?
one. It shows the internals if you want to learn more.
It shows me the internals.
Yeah, that's so strange of a concept. Find that stuff on the
Why are
internet.
you showing me the internals of a line?
Did you ask about the pendulum, the dual axis bearing pendulum?
Well, I was just wondering why you were talking about that. I don't know.
Because it tells you how it establishes vertical. It uses gravity.
Oh, really?
Yeah, sure. I'll let you think about it and then come back with a rebuttal.
Gravity, nice.
Yeah,
So-
repeating what I say is not a rebuttal.
How does it use gravity exactly in order to establish vertical?
The same way a plumb bob
So
does.
how does it work out horizontal then? Does it work out horizontal just basically as though it's a perpendicular?
Yeah, there's a second laser that's manufactured perpendicular to the vertical laser.
It's manufactured perpendicular.
Yeah, sure. How do you manufacture a perpendicular surface, though? That's a good question. Do you know the Whitworth method?
Go on.
Well, that's a trick question because the Whitworth method is actually to make flat surfaces. Do you understand how a perfectly flat surface is even made?
Made.
Yeah.
Go on.
Like if I want to make a cast iron plate as like a surface plate for metrology, and I want to make sure it's nice and flat, like a real flat datum to use as a reference for something, how do you make that?
Okay, you're going to tell us. I'm intrigued. Intrigued.
Well, you
Using
you
the
think you're
Whitworth
smarter than
method.
everyone, so I think you should know this already, especially if you're making an argument about geometry.
What? Geometry.
Did I talk too fast?
This is the Whitworth method. Is that in geometry or something?
No, but it exploits geometry.
It exploits geometry. Okay, right. So I'm not really bothered about exploiting geometry and the methods.
Are you concerned about how a flat reference is made?
Am I
in the real world?
concerned? No, not at all.
Do you even know how
I'm
it's made?
intrigued. You please tell us. Off you
I'm just
go.
surprised that you don't know.
Do you wanna switch your camera on? Do you give us a presentation, or are you?
Oh, AJM wants to talk about it. Go ahead, AJ.
Is he trying to? He's trying to slide out here. Nice. I don't
No,
think
there's somebody that
AJM
just
wants
knows more than you, and I want to talk to them about it.
No,
Mhm.
you're not going to get a save here.
I don't need to
was-
save. The
I was
conversation's
looking
done.
forward to hearing about
You
this
don't know.
Whitworth
Yeah,
method.
loving it.
Yeah, so am I.
What's this Whitworth method, Crookshank? Come on,
Bit of name dropping.
It's a method for making surface plates.
come on,
And from
explain.
surface plates, you can
Explain
make-
it.
Why don't you guys already know this? I mean, you're the experts on all this stuff, aren't you?
No, you're.
Well,
you're
this is
you're the
a
one that's
method
just
of
come in.
engineering, no?
You are definitely the expert on the Whitworth method. We're all ears. Off you go.
Yeah.
Oh, I'm not an expert. I just know about it.
Well,
They
explain.
probably float it on water.
Pass your knowledge, Crookshank.
Brian?
Come on.
What was that, Brian?
Don't help him, Brian. Don't lead him by
Anybody
the
know how
hand.
you make? Like, imagine that you want to make a flat table, and you're a furniture maker, cabinet maker, or something. You need a flat workbench, right? How do you make a flat workbench?
I'd use a spirit level, probably.
I'd put it through the sander.
Yeah, you could put it through the sander.
I'll get a carpenter to do it.
Mm-hmm.
How does a
I'd say
carpenter make a flat surface?
I'd put it through the sander. There you go. I'd get a load of plates together, boards or whatever, glue them all together.
That's what I've been doing.
Yeah, yeah.
Kuka,
How was the
also was a
sander-
carpenter. You're making all shit up when I listen to you. You make such a much crap is coming out of your mouth.
He makes
You never
everything
use
up.
a plump line when
we
you're
know-
lying
we
about
know-
plump lines.
Scorpion,
You
we
never
know
use one.
this. We know
Accurate.
this about Crookshank. Everything that comes out of his mouth is utter dirge.
No, but it can all be proven because I'm actually going to tell you how a flat
Are
surface
you
is
going
made.
to get on with the Whitworth method or what?
Are the houses still standing what you built or not, Crookshank? Are they blown away? But your plump bobs is not vertical.
It's a measure of flatness, guys.
Come on, man. Wake
Come
up.
on,
I wanna know
Whitworth.
No
how
reality. Don't lie about it. You're just trolling here.
Whitworth method. Come on, Crookshank.
I just don't understand why you guys don't know this already, since you're the experts on
Oh,
geometry.
come on. You're the one that brought it up. You're the one that's the expert with the manufacturing
Don't
process.
We don't know it because you haven't told us yet.
You don't know
Please.
it because you're lazy. You don't do research.
We're here to learn, Crookshank. So come on, teach.
Hey, Crookshanks,
Yeah.
Crookshanks. I work in construction. I create flat surfaces, level surfaces all the time. So I'd like to know how you're gonna, create a level surface.
Are we talking about what kind of precision are we talking about? Like a thousandth of an inch or a micron or something else?
Well,
What-
your
well, you
Whitworth
can tell me
method.
what
What
one you
does
want.
this work to?
Oh yeah, sorry, yeah, the Whitworth.
Yeah, AJM found it. AJM, go ahead. Tell us what you found.
No, come on, Crookshank. You don't need people to hold your hand while you're explaining things that you've brought into the conversation. So come on. You don't need somebody to hold your hand. You're a big boy now.
What are you whittling there in the background? What are you standing?
What's it got to do with you?
Are you sharpening a pencil or something?
Do I need to repeat myself? what's it got to do with you? Why are you obfuscating and changing
It's covering
the
up your
subject?
words. It's just making a bunch of background noise when you're trying to
Come on.
talk.
The Whitworth method. I'm waiting to hear you.
He's got the team in the background working on it now, writing out a thing, and he's going to be reading it out. It's going to sound very, very scripted when he talks about it in a minute.
No, I'm just establishing that you guys don't know anything about it, which is interesting for people to know that things are flat.
We have
Please,
said.
Can you
Have-
inform us about it?
How
Have we
can
not
you
said
establish? I don't understand
Have
how
we-
you can establish that anything is flat without knowing anything about how a flat datum is made.
It's in carpentry.
Yeah, Brian, it has nothing to do with carpentry, the Whitworth method.
Well, come on then, Crookshank. Get on with it. Educate us. Come on, please.
Is it
We're all
surveying?
ears.
Is it the datum for a theodolite or a level? Is that
No,
the Whitworth method?
no.
Well, that's the only datum we're really bothered about, really, right?
How can you prove something is flat without comparing it to a known flat surface?
Well, have you ever asked anybody to calibrate a surveying tool level?
No, I haven't.
No. Do you know what they actually are?
Yeah, I just showed you an example of one in that link that I
Right, so
gave here.
when you look through them, it establishes a horizontal plane of reference, right? And you can read through the
sure.
scope.
Right. How low the horizon is below that.
No.
How low buildings are because of the curve of the Earth.
No.
Yeah.
No, that's not how surveyors work. I mean, you're just imagining like you're looking through a telescope or something, looking at some
Yeah,
stars
with
or
a
something.
reticle that
That's
tells you
not-
something
that's
more.
not what surveyors' tools do, right?
Yeah, they can be used for that.
Well, yeah, but they can be used for looking at things, yeah. But the most bestly used for measuring heights above a datum that is set. But that's within a certain tolerance range, right? You can't go too far.
How far can you go?
Oh, I don't know. How far do you reckon? What do you reckon?
As far as you can
The
see.
best side, when you've been talking to the surveyors, because you've obviously talked to surveyors. I mean, you've told us.
In engineering school.
What do they say? You know, like how far away can your mate that goes away with his little stick with all the numbers on it? You know, when you were doing surveying, and you were looking through it, and you were reading the numbers on his stick. Or did you not do that? Was it all theory? No practical?
No, for theodolite, you don't need that at all. You just need one person. Theodolite.
Really?
Yeah. You know how the theodolite does? It measures angles. It doesn't measure height or distance.
Sorry?
You know what a theodolite does?
Yeah, it's a telescope, right? Built
No.
on a thing. And... Sorry?
What does a theodolite measure?
What
does a theodolite measure, Ev, expert in geometry?
You measure with a theodolite. The theodolite doesn't measure anything. You just look through it and measure the numbers.
What are the units of this measurement?
Depends. What measurement are you doing? Because what we're doing here is we're talking about level and horizontal and how surveyors
Surveying equipment, and I brought up a theodolite. And you have absolutely no idea what a theodolite does.
Yeah, of course I do. But if you're trying to measure a horizontal, right, then a theodolite can do that, right? You do realise you can set it at 90 degrees horizontal.
Yeah, right.
And like look through it and use it like a level.
Right. And you'll see that buildings are lower than they would be on a flat plane, and the horizon drops below.
Could you see through that and get an accurate reading? Did they tell you when you were in your civil engineering class?
Yeah, absolutely. Anything that's in the field of view, you can target. Anything. As long as you can see it through the field of view of the optics, you can use it. Target.
Really?
Yes. if you have anything to the contrary, you can present that. I mean, did you take a surveying class, or do you have an engineering
Yeah,
degree?
of course I did. I've done surveying.
Yeah, do you have an engineering degree?
I've got qualifications in surveying.
Yeah, but you didn't take any of these classes that we're talking about.
I didn't take the classes that you did. Obviously, I'm obviously
No,
did something
That's
different.
not.
than
That's
you.
okay.
Because we did surveying. When I did surveying, we had we used the horizontal was fundamental to it, right?
Sure, absolutely.
Right. So that horizontal, when you transpose the level from the horizontal, didn't have a distance in between the horizontals. It just seemed to get the same datum.
So, what's your point?
The point is that the horizontal datum is the horizontal datum. It's a straight line datum. It doesn't curve. And there's no measurements
Oh.
within it for
It's an imaginary
the drop
line. So what?
of the datum or anything.
Okay, so that's an imaginary line. Doesn't exist in reality. So what?
Well, it can be pretty easily demonstrated by a canal. And the
Right.
way that in between locks for a canal.
Okay, what about them?
Well, the water level within it, you would agree, is level.
Yeah,
right.
sure. What does level mean then?
It's the same level. It means horizontal.
Right. Sure. Okay, those are just words. So what?
So
Is
the-
it flat though?
Yeah, the
By
level
metrology
of the
definition?
water within the canal from lock to lock is
Yeah.
horizontal.
Okay. I don't know about that. Do we know it's flat though?
We know if it's horizontal, then it has the horizontal datum that can be established for height. Right?
Yeah,
That's
but
the
flatness is what you're
established height above mean sea level.
Yeah, which can be a
would be the same
spherical
all the way
surface.
across it, right?
Yeah, and that can be a spherical surface in 3D.
Not horizontal though, right?
It
A
depends on what
horizontal's a
context
straight
you're talking
line,
about.
right? Isn't it?
Yeah, it is.
Yeah. Well, you can't curve a straight line, can you? Or can you?
No.
Can you?
No, you
You
can't.
can't. Okay.
Yeah, but how do we know the surface of the water isn't or is flat?
It's horizontal.
How do we know that?
Because a water level, the tool, establishes a horizontal plane of reference. When you look at a canal in between locks, you've just established it's a horizontal plane of reference.
So I agree that 2 points in a water level will lie within a plane. But a canal, do you think like the top surface of all the water will be in a single plane?
Yeah, it's horizontal. It'd be the same horizontal.
You think it will? You're gonna have to back that
Apart
up.
from the little ripples in the water. But yeah.
Let's ignore the ripples. Let's ignore the ripples and come up with an experiment to confirm
An
your claim. that
experiment?
all-
To confirm that water level is horizontal.
No, an experiment to confirm your claim that the entire top surface of a still body of water will lie within the same plane.
That's what happens. What?
That's not an experiment.
How would you want it
repeating your claim.
demonstrated? Like with a water level? Do you want it logically? Do you want it geometrically? Or
No,
would you
let's do a
like it
real world experiment.
practical?
Let's do something in the real world that doesn't rely on assumptions.
Have you ever heard of float glass?
Yeah, sure, but that's not a big body of water now, is it?
Well, I mean, how big would you need to see what sort of tolerance for your curvature? How would you? What are you after?
Oh, you would need probably at least a mile, I'd say.
Okay.
Might be tough even over
Say
a
they've
mile.
got 27 miles of canal, but a
Yeah.
mile's easy. Go on, carry on. What would
Yeah.
you
We
need
can
to
do it.
establish?
You could do the method that Jeranism did.
No. Can you explain what would you need to establish within a mile of canal? And we've got a mile of canal. I can easily show you that, right?
Yeah,
What is
right.
it that you would need to establish to say it's level horizontal or level? What do you call it? What do you call your level? If it's not horizontal, what do you call it?
Specifically, we're talking about your claim that the surface of the water will all the points on the surface of the water will be in a single plane.
It's a
And to
horizontal
do that,
plane of reference, yes.
No, that's just restating your claim.
Yes.
You're just
Right,
restating
so
your claim,
yes,
you're not proving your claim.
I'm trying to say, what would you need to establish that that wasn't the case? Because it obviously is.
I'm not trying to say it isn't the case. I'm trying to prove your claim that it all falls within the same plane.
The water level establishes a horizontal plane of reference, right?
That's only 2
known.
points.
It's industry standard, and it's used practically like that, a level, by multiple trades within the industry. Right?
That's only 2 points, though. You're talking about all the points on the surface of a canal or a body of water.
Well,
you can always draw a plane between 2 points. So that doesn't get you anywhere. We need 3 points to determine if those 3 points are all within a single plane.
How big's your 2 points?
How big? I'm not talking about 2
What,
points. That's
yeah,
not.
you
That's
are.
not
You said 2 points, right?
Right. I only brought it up because that's what you talked
How far
about.
are those 2 points apart?
I don't have 2 points.
Well,
on
what are you
water
talking
level.
about? You've just said you've just established 2 points. We need 3 points. So where are the 2 points that we've established?
2 points of your water level.
Which are how far apart? 1 mile?
Oh no, you didn't tell me.
Well, let's say 1 mile. Let's say 1 mile. They're 1 mile apart. The same water in the canal is 1 mile apart. Right? That is the same level, okay?
Plane between those 2 points. That's easy. You can draw an infinite number of planes between those 2 points, actually.
Well, then, there you go then. Well, geometrically, you've proved it then, right?
No, because we need 3 points to define a plane.
Well, you just put one in the middle, and you'll say them 2 planes, and them 2 planes, and all 3 planes, they're all coincident, aren't they? They're all the same plane. They share the same plane, making them the same.
What if the third point doesn't fall within the plane of the other 2?
Well, that's so right. Now we're back to what you would need to establish to show that the water level isn't.
Yeah.
So are you suggesting that this other point, will it be higher or lower than the plane of the water?
And the plane of the water?
Yeah.
Or the plane going through the 2 outer points?
Yeah, well, let's say it's a mile, yeah. So half mile
Well, let's be
along the
very
water.
specific
Are
here.
you saying that is that point going to be higher or lower?
Hold on. Let's be very specific here. Take a water level with 2 points, separate them by a mile, and then we'll draw a plane between those 2 points, just like you want. And then we'll insert a third point connected to that water level in the center.
Sounds
Now, I think
brilliant.
your
That
question
sounds
is,
really familiar.
will that fall within the plane that was drawn by the outer 2 points, or will it fall outside that plane? My prediction is it will fall outside that plane.
Right, so higher or lower?
Higher.
Higher. Nice. Do you know what? Have you got any idea why? Can you have a look at the thing? Have you seen my? Put it in the wrong one. Have you seen my water level test? Have you ever been over it yet?
I haven't seen you do a water level test. I've seen you draw pictures.
Oh right. Have you never seen this one? Have a look in the live stream text now.
Oh, okay, cool. Is this a mile apart, though?
Well, this is the scale, right?
Sure. This, if you could scale this up and be able to see
okay,
everything.
Then, well, the green is 1 mile apart, let's say.
Right.
Right, and then the red ones, you see at the side there, they reference the centre one from the outside.
Yeah, those are superfluous. We don't need those.
Yeah, we do.
All we need is the green
the
ones.
actual way of showing you where the levels check the outside to the centre. Right? You must be able to see that this is how water levels work, right?
All we need is the green one.
Pardon?
All we need is the green one.
How would you know that the middle bit is higher or lower? How would you know
You'd have
that?
to cite it. We'd have to compare it to the plane that's constructed.
You've got the
outer
red
two.
ones. Can you not see? We don't need to cite anything. We've got the red ones that they're referencing the outside level with the centre level. You don't need, you can just look at all 3 in the centre, and that will show you the reference levels of the outside and the green and the red. Can you not see it? I mean, like, you know, when you were
Because
doing your civil
This
engineering
wouldn't
thing.
differentiate your hypothesis.
Pardon?
This wouldn't confirm your hypothesis because the effect that would make the
Small
center went
scale
higher.
model, right?
Why do you say pardon and then start talking?
So okay, let's scale this up to a mile. What would you suggest would happen to the green one in the middle?
The green one in the middle.
Yeah.
Compared to the outer two,
Yeah.
higher than the outer two and the green one. The outer two
Higher.
greens. Yeah.
Would the red ones also be higher
Relative to what?
relative to the green one and the outside
Which
of
green one?
the red one? Well, you can see the
Which
outside.
red and which green?
Listen, the one in the middle you've just said is higher. The green one.
Higher than what?
You've just said higher than the ends.
Right.
Okay.
Yes. Higher than
So-
the plane that goes through the ends.
Right, okay, right. So, but the red ones on the outsides are level with the green one, right? What would you suggest happens to the red one in the middle? Because you've just said the green bit goes higher. What happens to the red one
Relative to what?
relative to the other end of the red one? Because you've got the green one. You've just said the green one's level at the other end and rises in the middle. So the red one just goes from one end to the middle. It's like half the size. But you've got that green bit going up in the middle. So what happens to that red one in the middle?
Relative to the plane going through the outer 2 points?
Relative to the plane that it's meant to be on, because it's a water level. It's meant to be establishing a horizontal plane of reference, right? Can you see your problem yet?
2 points. No, and I'm trying to explain how you don't understand what you're talking about.
Well, no, you're the first one to go through this. You're pretty brave, right? Because nobody else has tried to go this far with it yet. They've normally run away.
No,
No, okay.
let me give up.
So the red one, it's only half the size, right? But you said the green one. I mean, what I would say is the middle bit of the green one is the bit that you don't actually need, because you don't put that middle bit in there, do you?
No, my hypothesis is that if you did this with 3 of them, plane established
three
by
of
the outer
them.
2.
There is 3 levels there.
What are you talking? 3 points that you're looking at in this water level on the green line, right?
Yep. Yeah.
Okay.
Yeah.
So my hypothesis is that if you separated the outer ends by a mile or more,
Yep.
and you drew a line between the outer 2,
Yep.
the level of the green one would be above that plane.
Okay. Right. Well, that's what
That's
exactly
just
what
the
we're saying, right?
Yeah.
So the red ones
That's exactly what we're
are
seeing. No, it's
completely
not a mile apart.
independent, and they are half the distance of the green one. So they reference the center point for you.
You can draw a plane between the 2 red ones. Yes, that's true.
Right. So
The same plane that goes.
it will go all the way through from end to end of the green one, right?
No, I don't think it would.
Oh, right. The red ones
Parallel.
wouldn't.
I don't think it would be parallel to the plane established by the outer 2 green ones.
Ah, right. So what you're saying is that the outer 2 green ones will establish a horizontal plane, but within that horizontal plane that they set up, the 2 red ones won't be parallel to the horizontal that they're already on.
No, they establish a different plane.
They
because of the
a
curvature of the
different
Earth.
horizontal
Yeah.
on the
Because of the
same
curvature of the-
horizontal though. A different, but the same on the
No.
same.
No, a different plane entirely, mathematically defined differently.
But how can that green one, if that green one goes from one end to the other, like the full mile, how can the first half a mile have a different horizontal than that big horizontal, and the second half have a different horizontal than that main horizontal? You're fucked, mate. Absolutely screwed. You best go run back to your mates now and go, geez, guys, we're screwed.
Because of the curvature of the Earth. That's easy. And gravity.
No. You can't have
also,
3
Bev,
different
Bev, I don't mean-
horizontal references.
Yes, you can. Why not? I
Sorry.
can make a reference any way I want.
Hello?
Go on, Spartan.
But I was just going to say that maybe ask him if you did like A, B, and C. If you started from the left-hand side, how would it work that way then? If everything was dropping away,
Yeah.
could you go through with that with him for me, please?
Yeah.
Do you mind?
You know, you have all the water dropping away from you, don't you? Because you don't actually have
That's nothing.
yeah. How do you do that? You do understand that, right, Crookshanks? It's not like the water. You said the green one would rise.
No, it would be higher.
You're right. Exactly. So the water would go higher.
It would be
Falling
higher
away
than
from you.
Yeah. Is it falling away from you, or is it going higher?
How can it be higher if Earth curve always falls away from you 360 degrees?
because you're standing on the high point and everything else is lower than you.
Right. So the
So it
water
cannot-
level drops.
Cannot be higher then, can it?
Of course it can. It's on the apex of the sphere.
Which bit
No,
is
you're
at
on
the
the apex of the sphere.
apex? Imaginary, Brian. Imaginary.
Oh, it's proven. Photograph was
That's true.
Zero.
It's going to be very painful for these people that
Oh.
think they're fucking educated, where really they've been brainwashed.
Yeah.
Yeah.
Brian, you're the guy who said that there
Painful
wasn't
for some and others, Brian.
and I showed
Wow,
you one
what's
and you
that?
got buttered.
Somebody
I
frying
thought,
bacon.
I thought gravity was the bending of space time.
Where'd you learn that?
Einstein, weren't it?
You think he's right?
No,
Let's-
it's
let's-
buoyancy
let's
and
not-
density.
hang
I know
on,
exactly
Brian.
what it is.
Brian, let's not change the subject. Let's keep him on this
Interesting
water level.
hypothesis, Brian. Do you have any experiment to prove that?
Brian, let's not change the
Sorry.
subject.
No, he mentioned gravity, not me.
Yeah. Well, he's trying to get away from the water level, isn't he? Because he's fucked. So
Oh,
let's keep
easy.
him on the water level.
It's there. Simple. It's very simple. So if your hypothesis is correct, why don't you go prove it?
The water is level already. It's used industry
Prove it.
standard. Yeah, and also
Different
the
than saying that the
tools.
plane. That's not the same as saying the 3 points would fall in the same plane.
They are in the same plane.
Prove it.
Do you? What would you
That's what you're
consider a
calling.
proof?
If we do this experiment and actually sight across,
What experiment?
you set this up and it's a mile long, and you can sight across all of them.
Why would you need to sight across all of them? We've just established that. You
confirm
don't
or deny.
understand anything about surveying, and surveyors wouldn't do anything like that over a mile anyway. So,
Yeah,
do
you
you
would.
understand any surveying methods that could do this?
You've obviously forgot the beginning of this conversation.
your empty claim, you mean?
Oh no, I have a link that proves something according to you.
You have a link that proves something.
Yeah, just the same way you guys do. Yeah, didn't you guys just link me something from Wikipedia earlier about the Saros cycle and call that proof?
Right, so go on, what proof are you offering up right now that the water level is not horizontal and it is
I didn't say that.
something else? Oh, it is horizontal.
I didn't say anything about that.
Right.
I said that if you had 3 points like this, the center one would not be in the same plane as the outer two.
But the horizontal is a straight line. That is the
I'm not going
claim.
to talk about
You
your,
saying
I'm not
it
gonna
is
talk in your
not.
nebulous terms. I'm not
Hold
going
on,
to talk
what's
about in your
important?
weird nebulous terms. All I'm going to say is that if you have these 3 points, like the green level, the center one will not be in the same plane as the outer two.
Right. You're wrong.
Oh, prove it.
What happens if you know, like I said before, A, B, and C, looking from the left to the right? That's one way of looking at the levels. What happens if you go to the right-hand side and look back to the other 2 points from the right?
I'll get
Do you understand what I mean?
I'll have a look for the Bowler's Canal. We'll pull that one up. I think that's the best way of explaining.
No, that's just a repeat of your claim.
No, it's
That's not proving anything.
This is the logical, because
This is the
obviously
logical part.
you're not understanding geometrical or practical.
Okay. So
Okay,
let's do this
right.
test.
Okay, right, you're here then. Are you live stream text?
Yeah, I see it.
Baller's Canal. Yep.
Right.
Okay. You're at point A.
Yeah, that's just drawing a spherical triangle on a sphere.
It's a triangle. Okay.
It's a spherical triangle in reality if you're on a sphere. So that's easy. I don't understand what the point is.
You're at
Easy
A.
to-
You're on a canal. It's a triangular canal, 1 mile long. In reality, right? Just
Yeah.
reality canal.
Yeah, sure.
Okay. So now, A to B is 1 mile. So what would happen to the water level within that 1 mile? Is it horizontal?
Are we on a flat surface or a spherical
Is it-
Earth?
We're on a canal in reality.
So a spherical Earth.
In reality.
Yes, a spherical Earth.
Like the canal. Well, like if that's what you
Yes.
think, right? Okay. So
All right.
you're at point A on the canal,
Right.
the
yeah.
surface of the water. You've got to go to B. What happens? Are you going to travel along a horizontal surface of water to end up
Yes, but it won't be a flat plane.
at point B at the
Yes, but it won't be
same
a flat plane.
horizontal plane?
Yes, but it won't be a flat plane.
It's a horizontal plane. What do you think a plane is? Do you not know what a plane is?
Yeah, I do.
A plane surface.
Yes. Yes,
Which,
I do.
in geometry,
Yes.
a two-dimensional surface.
Yes.
So that would be length and breadth.
Yeah.
Right.
Right.
So from A to B, you are a horizontal plane surface.
No, I'm not. I'm a person.
You travel along a horizontal plane surface of water.
No, you travel along a spherical part of the Earth.
So it's not a plane then.
Right. Sphere.
Oh, right. Okay. So what happens? Are you the same height? Or do you drop,
In what coordinate system?
well, away from the horizontal?
Established by what?
The horizontal would be established by a level, wouldn't it?
At what point?
From A, because you are going from A to B. The horizontal would be
1 mile?
set. Yes, 1
Yeah,
mile.
I think then your z-axis in a Cartesian coordinate system would be deflected by 8 inches.
Okay, brilliant.
Yeah.
See, that's in the downward direction.
Downward in the z direction relative to your original plumb line. Yeah.
Okay. Right, so now you've got there, you've gone from A to B, and you've dropped 8 inches. We're
Right.
going to go now from B to C, and that's also a mile.
Right.
Okay, what would happen? Would that be in the same Z downward direction?
Are we using the original coordinate system as established at point A, or are we establishing
Yeah,
a new
I guess-
coordinate?
Well, it's up to you. We're on the canal, which is like we've stopped. I guess we're making a new coordinate system, aren't we? According to you. So we're going from
we're
B to
using the
C.
same coordinate system that we
We're on the
established at
same
A.
level of water, right? We're on the same canal. It's
Yeah,
just
but that's a spherical
triangular
surface.
canal of water, and we've
That's a
dropped
spherical surface.
8 inches from A to B. Now
In Cartesian coordinates, that's spherical,
we're
though.
ready to no Cartesian coordinates are orthogonal, and the straight lines are all at 90 degrees, perpendicular to each other. But
Exactly.
anyway, let's
Not
carry
that
on.
useful for
B
spherical
to C.
geometry. Okay, you're just talking over me now, so I don't know what else to do.
B to C. What happens? That's a mile along a canal. So, can we assume 8 inches in the downward direction again?
No, because you're not traveling
that
in the
bit's not
perpendicular
down.
to-
So what
And
happens
not in
in
your-
that bit then?
You're just talking over me. I'm not even. I'm gonna wait till you're done.
Yeah, I'm done. Come on, downwards, 8 inches or not? Is this?
Not in the coordinate system that you established at A. No.
No, because we're going from B, aren't we?
Right,
Yeah,
right.
we stopped at B once we got there from A,
We're using the coordinate system
establishing.
today.
Well, I don't know. It's up to you. Like, I'm not particularly fussed. But let's go from B, because we're going from B to C. What happens on that surface of water?
Are we on a spherical Earth or are we on a flat plane?
We're in reality on the same canal we started off from, that's triangular in shape, with 3 sides being 1 mile long.
It sounds like you're using this example to falsify the idea that we could be on a plane, on a sphere.
I'm just giving it as a logical explanation.
You haven't given enough information.
What, from B to C?
Right.
You've just done A to B, and that's a mile. So that's the similar size length of canal as what B to C is. So the information that I gave you from A to B is pretty much exactly the same as from B to C.
Where's the x-axis defined here?
Wherever you want to define it. It's a horizontal.
Okay, I'll define it as a line going between A and B. The z-axis is perpendicular to the surface at A, and so the direction B to C is not perpendicular to the x-axis, or not in line with the x-axis, so it wouldn't physically drop 8 inches in the z-axis. It'd be some other trigonometric function of some portion of it. When you go from C to A, physically you're going upwards in the z-axis.
Upward water.
Mm-hmm. Yeah.
Yeah.
In the Cartesian coordinate system, if you define upwards that way.
Well, no,
which is not how we define it.
We're just talking about the surface of the water in the canal. So you're saying, in this particular canal of water, that A has to be the high point. That's where all the water goes uphill to, right? So you're always going down from A. But B to C...
Only in a Cartesian coordinate system, but not in a spherical coordinate system.
In different coordinate systems.
Right, because that's
canal,
what,
right? I don't think
but your
canal
coordinate system
cares what coordinate systems you use, does it?
Yeah. Yes, but up and down is defined by your coordinates. Yes, but your up and down is defined by your coordinate system.
No, up and down is defined by the direction
gravity
things go.
Gravity.
Well,
yeah.
What?
Defined by gravity.
Gravity?
Yeah.
What does gravity do then?
Defines downwards.
Down. What defines up then?
Opposite of down.
Gravity.
I'll wait till you come up with a proper rebuttal.
What's the opposite of gravity?
It's pushity.
Uppity. Is that the opposite? Whatever helium has. Helium has a lot of uppity.
Liftity.
Yeah.
And why does helium fall in a vacuum?
We don't live in a vacuum, do we?
No, wait a minute. What does helium do?
A helium balloon will fall in a vacuum chamber.
Helium's a gas.
Yeah, sure is.
So what would gases do within a container?
It would equalize the pressure completely throughout the container.
Expand to fill the container, right?
Yeah, equally. So the pressure was equal everywhere in the container.
So why did you say it'd drop?
Because a helium balloon would drop. It's in a balloon.
Yeah, because it's got a balloon, right?
Yeah, right.
The rubber. The rubber would go down, right?
Yeah.
How big do things have to be before they float in a vacuum?
It's not a matter of size. It's a matter of the...
What is it? When do things float in a vacuum then?
Whenever the buoyant force is larger than the weight of the object.
The buoyant force within a vacuum?
Well, the buoyant force is eliminated in a vacuum because it depends on the pressure gradient of the air around it.
Right, so nothing can float in a vacuum then?
Well, you have the kinetic velocity of the gas molecules. If you want to call that floating, I guess you could.
Okay. So big rocks can't float in vacuums then?
Kinetic value of gas molecules in a vacuum.
Yeah, it depends on the grade, how tight your vacuum is. Yeah, but no vacuum is perfect.
Isn't the moon in a vacuum?
Yes.
How's that floating then?
It's not. It's in constant free fall.
The moon.
Yeah. in constant free fall. It's in orbit.
Hey, hang on a minute. Is Mole Man?
Oh,
You've got a
Moleman's
thing
talking
about
now.
you've got a thing about vacuums, haven't you, Mole Man? Can a vacuum be formed? Mole Man,
Oh, he's typing. He can't talk.
who is he?
Yeah, he
Don't
can't
it have-
talk.
Don't it have to have a container to create a vacuum?
I think so. That's as far as I
Can't talk in VC.
On Earth, not in space, though.
know. There's no
Well,
vacuums
Mole Man disagrees with you. No
Yeah.
vacuums in
in
nature.
Yeah.
Bad luck, Crookshanks. Even one of your own side disagrees with you.
How does he disagree with me?
He says no
No
vacuums in nature.
Yeah.
Can't you read? It says in.
How's that
abstract.
disagree with me?
Well,
Pardon?
you just said the moon's in a vacuum, and Mole Man has just said no vacuums in nature. I had this conversation with him earlier.
Oh, it depends on your definition of vacuum.
Or nature.
Or nature. Yeah. Yeah, dear.
So what's supporting the Earth's weight then? Because we're supposed to be in a vacuum as well. So is the sun, and so are the rest of the planets.
Yeah, what's supporting our weight? Why do we need to support our weight?
You said it needs to support whatever's in there.
He's not.
I don't
he's
know
not
what you're
even
talking
got,
about.
We're presupposing that he's already got around this curving water problem he's had. We've completely gone round it now, and we're going on about things floating in mystical places again. He's still not confirmed how he knows there is a curvature to the horizontal.
Well, do your water test with 3 points and find out.
It's
But
a
we're moving
canal-
on,
It's
sorry.
a canal
Yeah, I need to see some evidence of your results.
of the results of the water being a level surface.
Level surface? No. Specifically, again, we have to be accurate with our words here. Will those 3 points form a plane?
No, level is horizontal. That is
Yeah, no, that's just
all
a
that
repeat.
needs to be established. Right?
No, you have
Yes.
to establish if all those points lie in the same plane, and you haven't done that yet.
No.
Yeah.
No.
Yep.
No.
That's
the
it.
only
That's the
thing
claim.
that we need to establish is that level is horizontal.
Can
Right.
be, but the points of those 3 water level readings will not be in the same plane. So go ahead and do that test.
If level is horizontal,
I don't care what words you think you can use to convince me. You have to do the test.
so I have to convince you that level is horizontal.
No, I'm not talking about level and horizontal. I'm talking about a water level with 3 points on it, separated by a mile. Will all 3 points lie in the same plane? That's all I'm talking about. Nothing
because
else.
level is horizontal.
I don't think they will fall in the same plane.
Right. Well, in that case, then it's up to you to prove some sort of way to show that level is not horizontal.
I'm not talking about level and horizontal at all. I'm talking about those 3 points of the water.
Yes, but that test,
Yeah.
right, is just to show the people that don't seem to understand that level is horizontal.
I don't care about level and horizontal.
It has no other
I'm talking about the 3
purpose.
points.
It
I don't care about your level and
no
horizontal.
other purpose.
Okay, so let's do this test and see who's right.
Level is horizontal. Can you not see? With
I don't care
test?
about that. I don't care about that. I'm not talking about level and horizontal. I'm talking about points of your water in your tube.
Yes, which goes to show that all 3 horizontals on that thing are parallel to each
I would
other.
like to see some proof of that. It sounds like a claim. Proof.
What? You said you've done civil engineering and some surveying. What
Yes, and we use the curvature of the Earth.
What does an auto-level tool do?
I'm not talking about all levels. I'm talking about the 3 points of water in
What
your
does
tube.
that establish as its level?
I'm not sure why you're changing the topic.
It's exactly the same topic.
No.
Level is horizontal. I'll say it again.
I didn't bring
You
up
give me
level and
loads of
horizontal.
chance to say it.
I didn't bring up level and horizontal.
What did you do? You did, because you said there's a hump in the middle of it. So you
Right,
you brought up level not being horizontal. I'm pointing out
Oh,
to you
I didn't say that.
that level. You did. You said there's a hump in the middle.
Yeah.
Right. Well,
Right.
how can it be horizontal if there's a hump in the middle?
How can what be horizontal?
The level.
The 3 points of the level, or the 2 points of it? Quiet.
Yeah, I'm still trying to work out what you're talking about.
Oh,
Do,
no
do
doubt
you
about
don't
that.
obviously still don't understand what a level is, do you?
oh, I think
Oh,
I do
that's
more
good.
than you can imagine.
I'll put the picture up again, right? The level of the two red ones check the level of the green one in the center. There's no need for that one in the center, is there? Because the actual tool level just goes from one end to the other to establish a horizontal plane of reference all the way across between the two. Now, you could show that by actually transversing the level from one end across the center to the other. It would be the same level all the way across. Now, within this
but you get the
test,
same result on a curved
I've
earth.
put one in the middle to show you and to get you to say it should be higher. Why do you
You
think?
would get that same
Why do you
result.
think that one in the middle should be higher
Higher than what?
than the two ends at the other end?
That's not what I said.
Yeah, it is. You
No.
said the two outside ones would be lower than the one
no.
in the middle. Yes, you did.
Here, I'll say it. No, I'll say it again, and you have to listen because you're getting it wrong.
That's
The one in the
exactly
middle-
what you said, Crookshank. You said
one
the
in
one
the
in the
middle,
middle
It's
would be
recorded.
higher.
Higher than the plane established by the other two.
Yeah, a horizontal plane of reference. Now,
Yeah,
let
it'd be
me go
higher.
back to it. That middle one wouldn't be there. It's not even needed. Because the horizontal plane would go from one end to the other.
Can I see the horizontal plane?
Pardon?
Can I see the
No,
horizontal
but
plane?
you've just imagined the bit in the middle being higher than it. Didn't you? You
right.
did that all on your own.
No,
Nobody
we could.
told you to
If we
say
could
that.
sight across all three of them, if we could sight, then we would be able to
No.
see it.
The red ones reference the outside level to the center. They show you that they are all on the same horizontal. But
Yeah, but that
you've
would
just
happen on a curved
imagined
surface.
that the middle one is higher.
Yeah, but that is the result you would expect on a curved Earth with gravity. You'd expect
I
exactly
only
that.
expect reality
Right?
things.
How
to
do we
happen
discern
in
reality from this
reality.
test? This
You
test
look
doesn't
at
help.
it.
Shh. I understand what you're saying, but this test does not help you discern reality.
Are we
You interrupt a lot.
doing ASMR now?
Freak.
Come on, carry on. Shh.
The result that you're describing is exactly what you would expect to see on a curved Earth, a spherical Earth of a large radius with gravity.
A large radius.
Yeah.
See from where? Which advantage point?
The one that he just described, we were traversing the level, looking at it.
Traversing the level, looking at it.
Yeah, that's what you just talked about, walking along it. Do you know the word traverse?
Why are you walking along it? What are you talking
It's
about?
the scenario that you just described. I don't know.
I said you could take the one end of the water level and walk all the way across with it, couldn't you? And you could stop at every point. So you wouldn't
Right.
actually
No.
need that one in the middle. That's what
Yeah.
I'm saying.
And how does that help you discern the
please.
shape of the Earth?
Please just put him through from left to right. You know, like one point A, B, and C with the drop,
Okay.
and then to the right hand side, and
So
do it back. the other
We're
way.
going to start
Just
on
so
the
he can-
left-hand
so he can see
side.
what he thinks.
Start on the left. We're going to work our way to the middle. What happens from when you go from the left-hand side to the middle? in the green water level. Crookshanks. Has he left yet?
No,
What are you talking
he's
about?
still-
Talking about the water level test, right? You're at one end of it.
Yeah.
And then you go to the centre. You've gone from one end to the centre. Now
Okay, so I'm just walking along it.
Yeah, you said you calculated that middle bit would be higher. Did you? How far did you calculate, or did you just imagine it'd be higher to some sort of point?
No, I can calculate it.
Okay. Do a quick one.
How far apart are the two ends of the water?
Sorry?
How far apart are the two ends of the water?
How far apart are the two ends of the water?
How long is the water level?
We said a mile, didn't we?
Oh, okay, yeah. So I predict that if you were to draw a plane between the two outer ends, then the level, the water in the center one would be higher, 4 inches higher than that plane.
4. Okay, so
Yeah.
we're walking from the left to the middle.
Right.
That now we're at the middle and we've gone up 4 inches.
Relative to the plane between the two outer points, yes.
Okay, and then what happens to if we go to the other end then? What would
And
be?
you would return to the same plane.
Right, so we'd have transversed a mile and had 0 drop. So that would have been a horizontal all the way across from one end to the
It'd
other.
be up. You'd have gone up and then down though, like a curve.
Up 4 inches and back down 4 inches to end up at
Yeah,
the same
that's right.
horizontal point.
Yeah, sure. That's a
So-
chord through a circle. Do you know what a chord is?
Of
So
course.
we wouldn't have been at the highest point when we started then.
Not relative to the plane drawn between you and something that's a mile away.
But you're always at the highest point, and you're always on the top of your bowl. Everything curves down and away from you, Crookshank. Don't you know this? This is 101 with living on a bowl.
Also, if you were at
Yeah,
one
but the
end of
coordinate
it,
system we established is based on the center one,
if
not
you
the
were
not
at
the
one
starting
end
one.
and dropped a plumb bob and that had a horizontal from that, what would
Yeah.
happen? Would that be the same horizontal as what you're going to walk across the water level?
No,
No.
no, I don't think it would.
Oh, dear.
Because plumb lines aren't parallel. We know that.
Right, you've done a great job there, Bev and DP. But if I could ask a question,
Yeah,
because
yeah.
I wasn't able to, I was just a bit busy. Yeah, so can I just get this clear then, right? So if we're on a canal and it's a mile long, we're at point A, which is the left-hand side. Let's forget, don't worry about the humps and bumps in it. Just let's start at point A, and that's our position where we're going to have a horizontal line. That's so let's work it alongside the canal. So we want to go a mile away. The middle point between you, so point A and C is B, so the middle point. Would there be either a drop or from the initial point, or would it go upwards, or would it stay level? Initial point. Do you understand?
Depends
what I
on how
mean?
your coordinate system is drawn.
I want to go from A to C. That's 1 mile. Yeah. But at point B, is that higher or lower than point A?
In what coordinate system?
The coordinate system that I explained to you next to
How
the
is this
canal,
coordinate system
looking
defined?
on reality.
Okay, you're gonna have to give me a little bit more detail than that, because in reality, the way that we define coordinate systems is a little bit more than that.
No, right. You're with me. We're stood on the canal next to the sight lamp, and we're looking through it. And let's just say we can see a mile. That created a horizontal plane. So if we went to the middle, you're saying it's 8 inches drop from point A to C. So in the middle, what would point B be from point A? You're saying 4 inches upwards.
B from A. So I established my coordinate system at A, is what you're saying?
He's all
You
hooked
establish
up
it.
on coordinate systems.
Yeah,
you
yeah,
Yeah.
no,
still
maybe
have to,
we'll just.
That's what we
I
do
don't
in
think-
geometry.
Yeah, I know, but I'm just saying that this is like, forget all that other stuff. Let's just be real and we've got a level. We're looking through it, and like we can see a mile and it's an 8-inch drop.
What kind
And
of
that means
level?
that-
Theodolite?
Sorry.
What kind of level? Like a theodolite?
Well, just like a site dumpy level that looks parallel, like horizontal.
Like a spirit level?
Well, it's
No.
kind of a spirit level in essence, but it's sending out one straight line from point A.
He means an auto level, a dumpy level. He means a site level. I know
Okay.
you
A
don't
theodolite would be
understand.
good for that.
No. He
No,
means
not
a
angles.
site
We just want to send
level.
one straight level, yeah. So hold on. Okay, all right, let's think of it slightly differently. So if you're at point A and you're saying there's a mile drop to point C, yeah, the whole entire
Right.
distance is a mile and there's a drop of 8 inches, yeah.
Right.
Okay, right. Are you happy with that?
Yeah. Yeah.
So it's dropping away 8 inches from the parallel horizontal line of the level.
Yes.
Right, okay, great. So what I'm going to do now is I'm going to go to point C
Right.
and I'm going to look back the other way to point A.
There you go.
Right.
I've just done an ABC thing for you. If you,
Let him talk, Bev.
there you go.
Let him talk, Bev. I want to hear what he has to say. Oh, he's just gone on mute.
Sorry, my lad came in. Okay, right.
There you go. I've done an ABC for you, so just so Crookshanks know where you're talking about A, B, and C.
Oh, nice one. Whereabouts is that, Bev? Oh, I see, on your thing, in the live stream.
22.
Okay, yeah, so...
Oh, we're not talking about the canal anymore. We're talking about...
Yeah,
this,
reality. The canal. That's what I am talking about.
Yeah, but the picture Bev posted is not of a canal.
Oh, I see what you're saying. You're saying that isn't the canal.
It's a water level. A, B, C.
Yeah, but he talked about a canal. Go ahead, spot on, whatever her name is.
But what I'm saying is if you're at point A and C is 8 inches lower than point A, and you mark that with your level, yeah, and you mark it on a rod next to the canal, then you walk that mile to point C, set your level up on that point that you marked, 8 inches lower, and then you level across back to point A. Would that go back up to the 8 inches, or would it go down 8 inches, making it 16 inches lower than the original point A? That's my point. Hopefully you understood that.
Depends on what you mean by up and down. It's kind of hard to define when you're on a ball.
Yeah, I guess it must be.
You have to be a little more specific.
Do you have an answer to that, though?
Yeah, I said it depends on how you define up and down.
Yeah, this is how he's going to define his new excuse. I've seen this. It's in this.
Yeah,
coming
so it's all
from,
direction, all movement's relative,
yeah,
right?
you can't tell
And when
what
you go-
coordinate system you're using or anything, can you? I mean, like, up
Yeah,
could
we
be
can't. We
down
can
if
use
you
the
change
GPS
a bit.
coordinates.
If you walk a bit that way, then left might be right a bit more than it was left, than just a bit forward.
No,
Especially
we
if you
can
turn
use
around.
the coordinate systems established by surveyors and geodesy and GPS, which you guys all use when you go.
Horizontal and vertical, right? They don't move. They're always
Well, that's
the
Cartesian
same
coordinate.
reference frame, aren't they?
No, they move whenever you reestablish a new coordinate system for your location.
Well,
Yeah, I mean,
the
think about the
entire
Romans.
the entire coordinate system changes, does it?
Yeah, sure. Think about the Romans. When they made maps, Rome was the center of everything. And so if something was to the south of them, it was upside down on their map.
Do you want to do this now? I mean,
Sure.
we can practice this one, I suppose. You know, you want to do Cartesian reference frames, and Z is going to be what, your extension of a radius, right? Can we say that's what this is the way we're playing this game, or the way you're playing this game? Cartesian coordinate
Not interested
systems,
in playing word
X,
games
Y,
with you.
Z, right?
Not
And
interested
X,
in
Y
playing-
are the horizontal plane surface. Z is the vertical height.
Not interested in playing your word games. I'm gonna talk to the other guy. Spot on level, dude. What else did you want to say?
I'm making the brew. He's obviously running from it, so if anybody wants to play Cartesian
We're done with that one.
Hoo-ha. What, is that two-dimensional Cartesian coordinates?
Oh, 3 dimensions.
Right. So the surface of a sphere, it's definitely got 3 dimensions, right?
Yeah, sure does.
Nice. So you wouldn't go with don't know who it was. Most of the Twitter dudes. You're not from Twitter, Crookshanks? Is it? Remember the big thing that they had with the 2-dimensional coordinate system, and the surface of a sphere being 2 dimensions.
He's run away now, Bev.
Has he?
Yeah, he's just bailed out.